So on our home screen here, I'm going to click on Project Settings, and we're going to start in Job Settings, and we'll actually start in the Design tab. So I'll go ahead and open that up. And in our Design tab, we have Design Settings, Plate Design Settings, Moment Plate Design Settings, Flange Plate Clearances, Weld Design Settings, Seismic Weld Access Holes, Schedule of Minimums for Structural Members, Schedule of Minimums for Single Plate Shear Connections, our Field Clearances, and our Composite Reaction Factors. So to start, I'm going to open up Design Settings, and in here is where we could change our connection design method. So when we set up our project, we chose India for our connection design method. This is where you would go to change that if you would want to specify something different. Also, when we set up our project, we saw this round cut dimension. You can either specify 1 millimeter or 5 millimeters. In here is where you'd be able to change that if you specified it wrong when you were setting up the project. Below that, we have the ability to design non-AISC single plate shear connections. And I'll move on down through the tabs over here. So next we have our beam design loads. In here we can specify how our default loads get calculated, whether that is a certain percentage of the uniform allowable load or the maximum web shear. We could check on the minimum setup connection, and what that will do is that will automatically lower the loads until it can pass whatever we have in our setup for our minimum connection information. Below that, we have some different settings for our beam moment connections. So we can specify the percentage of our maximum allowable moment. Do we want to design a moment connections for greater than 100%? We can design for a seismic moment connection design. Do we want to use inner flange plates for beam splice moment? And what our seismic moment frame type is, we can either choose OMF, IMF, or SMF. Next we have connection material specifications. Here's where we can specify what our default material connection steel grades are. So we can change for T sections, angle sections, channel sections, and our base and cap plate schedule. Below that we have our beam composite design. So if we are using composite design, we can specify what our composite loads are, and then what our strength is for, and then what our strength and thickness is of the concrete. Below that we have braces. Here's where we can specify what our percent of allowable tension and compression loads for horizontal and vertical braces is. We have the option to add gusset beam interference forces to beam, so we can pass some of those forces from the braces into the beam connections. And if that is checked, we can specify what our UFM special case design is. What our wide flange vertical brace to gusset flange connection is, we can either specify flange claw angles, paddle plates, or set that to none. And then down at the bottom, what our minimum bolt rows for horizontal and vertical braces is. And since we didn't change anything within this design settings window, I'm going to go ahead and just cancel out of this so that we can get back to our job design settings. And next I'm going to go into our plate design settings. So in here we can specify the distance if we want to design a shared gusset. We can set what our multiplication factor is. Do we want to design by first incrementing the plate thickness or the plate size? Do we want to round our flat plate values? Do we want to always provide our transverse beam stiffeners? We can specify what our minimum beam stiffener plate thickness is, and then what our total stiffener clearance is set to, and then do we want to use HSS column reinforcement plates. Again, I'll go ahead and cancel out of this, and I will go into my moment plate design settings. So this is where you can specify setup for your moment plates. Do we want our stiffeners coped or clipped? Do we want our corner operation for flange stiffeners sized by either total length or dimension added to corner fillet radius? What is our total moment stiffener clearance? When we're framing to a column flange for our web doublers, what is our minimum doubler plate thickness? The doubler plate extension above top flange of beam, the doubler plate extension below the bottom flange of the beam, and then what side is our doubler plate on the column web. We can set that to both near side or far side. Then for flange stiffeners, we can design the depth as needed, when needed use full depth, or use full depth at all connections. And then we have the ability to determine plate thickness by increasing beam flange or flange plate thickness by percentage, by a dimension, or you can just design that as needed. When framing to the column web, do we want to determine the welded moment flange stiffener thickness by increasing beam flange thickness by percentage or dimension? We have the option to extend the plate, and for the stiffeners, do we want those flush to top, centered, or flush on bottom? When framing to HSS column, we have the ability to specify if our flange plates are wrapped around the column. And then lastly, if we want backup bars on our welded connections, here's where we can specify the settings for those backup bars. So we can change the material type, the material grade. If we want to create solids for backup bars and modeling, you can check that option on right here. I'm going to go ahead and cancel out of this window, and I'll move on to the flange plate clearances. So this window allows you to specify your gaps and clearances for moment connections and braces. In this table, we have the ability to specify what the gap is going to be per nominal depth size. So when using a wide flange brace, what is the horizontal brace bottom gusset gap set to? Then we also have the ability to set the gap for the vertical brace paddle plate. And then lastly, what is your maximum gap for a single filler plate? Cancel out of this, and we'll go into the weld design settings. So this is where we can go in and specify all of our basic weld information, as well as our welded moment information. So we have our weld standards up top. We can choose our tensile strength and electrode type. Do we want to perform chamfers? Do we want to show the weld length on symbols? And then for moment connections, what is our weld gap, our reentrant cut radius, our root face dimension, our web setback dimension, groove angle. We can specify our cut radius, length, depth for our alternate number 1 reentrant. If we do have a reentrant cut, we can specify is that alternate number 3 or alternate number 1. For alternate number 3, Copefield shop weld, is the cut type parallel to flange or perpendicular to the web angle? For weld size, what is the minimum for the job? What is the maximum for non-strength connections? For HSS brace weld, what is the maximum field weld for HSS brace? And what is the minimum ratio weld length to HSS brace width? And then for weld pattern, on the base and cap plates, we can specify if we want that 2 faces, all around, all faces, and all faces with a seal. And if you do have a seal weld, what the seal weld size is at the very bottom there. I'll cancel out of this, and we'll take a look at the seismic weld access holes. So if we take a look at the picture here, we can see that the values 1 through 5 are controlling different dimensions for the weld access hole. In this window, we can also specify what the web setback is, what the weld gap will be, and also the dimension for the root face. So in this window is where you would set up your specifications for each access hole type. In this case would be A through O. And then And then in the local material file is where you can set the designation for which access hole type you would want to use. I will go ahead and cancel out of this. We won't go into the schedule of minimums as this will be covered later on. Next, I'll go into field clearances. So for our non-auto standard connections, we can specify what our field clearances are going to be for shear plates, shear tees, our clip angles on supported or supporting, end plates, seats, splices, or plain end. For our brace connections, when it is braced to another or braced to gusset. For joist connections, when it's plain end and bearing, or whether it's a seated bottom cord extension or knife plate. For welded connections, when it is braced to supporting member or brace to brace. For our end plate field clearance, if we want to round up the field clearance or not. And then for our steel to concrete connections, what is our end and pocket clearance, and what is our pocket grout thickness? So we'll go ahead and cancel out of here. And lastly, we have our composite reaction factors. So based on our nominal depth of the members, what is our Rx factor? This allows you to set a percentage or a factor of what the composite design is going to be designed for. I will go ahead and cancel out of this. And next we're going to be taking a look at the settings for our bolts, washers, and holes. So to get back to our settings, what we can do is we can simply just go up here and click on the job button here, and this will take us back to our main fabricator and job settings. And now what we can do is click on our bolts, washers, and holes tab. Inside of the bolts, washers, and holes tab, we have bolt settings, bolt specifications, nut and washer schedule, washer settings, and our user slot lengths. So to start, I will click on our bolt settings. And inside of here, we can specify what our default bolt class is. Do we want to make all bolts automatic, field bolts, or shop bolts? With this set to automatic, the system will automatically decide on which bolts will be shop and which bolts will be field bolts based off of our project settings and what our particular framing situation is. Below that, we can specify what our minimum bolt length is, what our min and max stick through is. Do we want all metric bolt lengths in 10mm increments? Do we want washers to prevent shank out when needed? What is our maximum bolt gaps for field bolts and shop bolts? And then we can specify our available bolt diameters. These are the bolt sizes that we want to specify to be allowed inside of this project. What is our hole allowance? Do we want this based on job units, our bolt units? Below that, we have our default bolt criteria. What is our default for our non-moment bolts? So we have the ability to change our bolt diameter, and if I change this, I have the option to apply to all auto standard connections. And then the same for the bolt type. I could change the bolt type there, and if I do, I can choose to apply that to all auto standard connections inside of the project. We can also specify our moment bolts, our vertical brace gusset to supporting, and horizontal brace gusset to supporting, and then a series of different joists. So we have K, KCS, LH, DLH, and SLH. We have G joist bolts, BG, VG joists, and CJ joists. You can change the flush frame joist connections and our HSS welded brace erector bolts. And then lastly at the bottom here, we have the ability to specify our bolt edge distances based off of what our bolt size is. So I will cancel out of this window and I will open up bolt specifications. This list is based off of our design method that we chose, which in our case is set to India. In here we have listed our bolt type, the bolt grade, what our connection method is going to be. We have some different hole factors, our yield strength, ultimate strength, and our nut grade. If we wanted to add in our own bolt specifications for one that isn't listed here by default, we could do so in one of the empty spaces down below. We'd want to make sure we have all of these fields filled out all the way across, and you'd want to ensure that you have the appropriate yield strength and ultimate strength filled out, as this will affect how your calculations come out. We'll close this and open up the nut and washer schedule. Here we can specify the grade name and nut type. For the nut types, you can have heavy hex, heavy square, or jam nuts. And then in a washers tab, you can specify the grade name and the washer type. And for the washer type, you can see listed down the list here, we have hardened, flat, bevel, direct tension indicator or DTI, square plate, round plate, hillside, or a material plate. Go ahead and cancel out of this and go into the washer settings. This is where we can define the default washers to use for each hole type in different configurations. So these up top will be our default thicknesses for our different washer types. We can then down below go in and specify by bolt type what we want to use for what type of washer. So for standard holes, we can specify a primary or secondary under the head and under the nut. We can specify based on the hole type, what washer we want, and how many washers we want. And then we also have the options to be able to use tension control or TC bolts. And we have that ability for both shot bolts and field bolts. If I cancel out of this, I'll click on user slot lengths. So this will allow us to set up user-defined slot lengths based on bolt diameters. You have the option to set up for slot length number 1 or slot length number 2. The default long slot and short slot lengths will not be affected by this window. This is a completely separate user-controlled slot length. Now I will cancel out of this, and I will go back to my job settings. And next we'll be looking at our material grades. Material grades is where you can go in and set up your default steel grades and production standards for different material types. So if I click on the angles here, we can see that we have some default steel grades set up for angles. If we do want to set up our own or add in our own steel grades, we can do so, but the same applies here as it did for the bolt steel grades. If you add in your own, be sure to appropriately fill out these fields as they will contribute to how the system makes these calculations. The first line in this window that says default 1 will be the default grade used when adding those material types and will affect any material that is already added into the model. You can always come into this window, select the steel grade, and use the move up or move down buttons to make adjustments to your steel grades. So if I wanted to move this one down, say, I could use these buttons to move that line up or down. I'll leave that be our default for now. And these same settings can be applied for all of the other materials such as our cruciform, channel, flat bar, grading, HSS TS production standards, HSS TS grades, pipe, plate, rebar, round and square bar, shear and threaded studs, our turnbuckle and clevis, and pins, our wide flange grades, and our WT grades. I will go ahead and click on job again so we can go back. And next we have our modeling tab. If I click on modeling, this will allow us to set up general modeling settings. We can set descriptions, revisions, some different color settings, and some offsets. You can also set up different zones and sequences. And for this project, we will need to do so. So we can go ahead and open up our zone and sequence tab. And right now you can see we only have one sequence set up. We need to change that to 4. So for our maximum sequences up here, we can just type in the number 4. And once I tab out, you can see that down below our sequences automatically change 1, 2, 3, and 4. And that's set up for our zone number 1. So if you wanted to have multiple zones, you can come down here and change zones, and then you could apply which sequences go with which zones. In this case, we're just going to have one zone, so I will keep the one zone with the 4 sequences. And now what we're going to do is we're going to rename these sequences. So to do this, what I can do is go down here to sequence names, and then I can just type in what I want my sequence name to be. So in this case, I'm just going to rename that to 1A, rename this one to 2A, 3A, and 4A. And then you can just say OK to this window. And you can see that that change gets made under the sequences up top there. Now that we're done with that, we can say OK to this window. And I will go back to our job settings. Next is our custom properties. In this basic training course, we won't have enough time to get into any of these settings, but this is where we'd go to set up custom properties for job properties, member properties, material, hole, bolt, and weld properties. We do have our concrete and rebar tabs down here, which we won't get into right now, but this allows you to set up concrete and rebar information if you do have that information present.